Hello everyone, this is Muhammad Aslam Al Hindi and you are learning SolidWorks, and this time we are going to learn about the simulation or FEA, finite element analysis. We do this kind of analysis or simulation to either know the stress distribution in the model when certain force is applied, or there are certain other uses of this simulation. There are many domains which are fulfilled using this simulation or finite element analysis. So let's go for that. Let's go for SolidWorks add-ins and click on simulation, and it will be taking some time to show up the simulation here. Yeah, it's here, and I can add it from here as well, from the add-ins. SolidWorks simulation, it has been checked now, and clicking OK. So we'll be starting a new study. We will be discussing the impact of force when we apply force over this model. We have to fix some of it and you have to keep some of it. So anyways, let's begin the new study. Let's start the new study, and we will be applying a static study. So we'll be finding out the stress distribution. So let's make this study as a stress testing. Now clicking OK, it automatically sets up various parameters which I have to input, and then after running this study, we can find out the results. So let's first of all fill up these different things. And the number one is fixture connections, and going for the contact set. Here you can see there's nothing, there are no two objects, it's a single body, so this is not required in itself. So just closing these connections and now going for the fixtures. Now there are different kind of fixtures that we can add. One is fixed geometry. Clicking for that, we can fix a certain edge, a certain portion, as you can see here. So let's assume that we are fixing this one. This is the chassis for a car, an electric car. So I'm fixing this one, along which the rear wheel will be placed. So clicking OK, you can see now this rod is fixed. Or there are different other options in the fixtures. We can go for the rollers. In this case, if we apply the roller, then that particular part can only, you can say, slide around that portion, but it won't go beyond that portion, beyond that area. If you can see, this is the plane, so it can only slide to and fro along the plane, but it can't go beyond the plane. The third one is a fixed hinge. In this fixed hinge, you can see we can choose any circular face, any cylindrical cylindrical portion from the model, and so along that model the hinge will be hinged, and that will be fixed, and things will go rotating around that hinge. So we have fixed this one. So now we have to apply the external loads. Now let's add the force, and Now let's try applying the force here, and here you can see the force is being applied from all the directions. Why? Because this is a cylindrical body, so in the totality as a whole, the net force over the model, over the rest of the model, will be 0. So we can't go with such kind of geometry. We can't take cylindrical geometry, so cancelling it out, and let's add something else. I had suppressed those components. I'm adding this squarish extrusion here, and the same way the one on the other side at the same distance. So now we can apply the force, a linear force, and we have to apply the force in this direction, going like this. So let's go for the external loads. We can apply the force here, clicking here and clicking here, and applying 1000 Newton of force here, and this is per item, or it can be total. We'll be making this as total force, and clicking OK. The force is applied. Now is the final part, which can be a bit tricky. We have to create the mesh. Let me tell you, the simulation or the finite element analysis can't be done on this simple model. The software first converts into a mesh, as you may have seen a wire mesh. Let me show you how the mesh would be. So let's apply the mesh, clicking OK. Just click OK and it will start meshing this. And once the meshing is done, you can see how the teeny wires or the meshes are connected with each other. The meshing has failed. Need to fillet 3. Okay, let's do something else with the mesh. Create mesh. And these are the mesh parameters. This was a standard mesh, so we can, since there are so many curvatures or rounded surfaces, so we can go for curvature based mesh, and then in the advanced we can make it a 16-point mesh, 29 points, or 4-point mesh. We are just keeping it 4 point. Again clicking OK. Now let's see what the meshing does. So the meshing is getting up, and once the meshing is done, I can show you how the meshing is done. Let's see if it succeeds, and it should. Yeah, done. Now you can see this is the meshing. Now these are 3 points. This point is connected with other points, so this is basically a kind of wire mesh, a kind of a meshing made up of wires connected with each other, or you can say this is a skeleton kind of model. So now here's the force, and here is the fixture. This beam is fixed. So now we have to just run this study. Just click on the run this study and let's see what happens. Yeah, it has started, and sometimes it takes some normal amount of time, and in some other cases it takes either a lot of time or it just fails. So we have to make adjustments in the it's done. That's great. So you can see this is how the force is being applied and how it makes the changes, how it deforms the chassis. So there are basically three kind of results that are provided: the stress testing, the stress distribution, and then is the displacement test. Let me show you. And then is the strain. So let's go for the stress first of all, and we should edit the definition. And one more thing I should tell you, clicking here we have to apply the material and apply or edit the material. So this was the aluminum alloy and I have chosen for that already, so I don't need to apply once again. So let's go for the stress test and edit the definition. For the better and safer results, instead of 1 minus stress, we should go for this P1 minus P3 stress intensity type of stress, and then instead of Newton per meter square we should go for Newton per millimeter square or megapascal. And then this deformed shape, this is the deformed shape by applying a scale of 399.83. Instead of that we should go for true scale, because that will be showing us the real deformation that will be happening in the model. And clicking OK, you can see in the reality the deformation will be only this much and not that much which was shown by the previous scale. We can, let's just restore that value, that automatic, clicking OK. That automatic is used basically to see how the deformation will happen in the model. And let me show you, we can also animate it. So now you can see this is how the deformation will happen in this model. You can better see it, and I hope you will be enjoying this, because this will be the first time you will be seeing something deforming or animating in SolidWorks. I hope so. So this is the animation that we can do. Anyways, let's just resort back to the true scale, clicking OK. Yeah, this is the true scale. And now let's once again go for the material. We are going to the material to see how much is the tensile strength that it can offer. This is in millimeter per square. We have to change it to megapascal. Now you can see it is 109 megapascal. That is the tensile strength that it can offer to you, and bending is basically the tensile strength. So we have to see here, yeah, e raised to power 1 means 1.4 becomes 14.81, because e raised to power 0, e raised to power 1 means we have to multiply this figure by 10. So it will be 10 multiplied by 1.481, so 14.81 megapascal. So under the total external load of 1000 newtons, the maximum stress that can be built, this red zone is showing the maximum stress. So the maximum stress that can be built is 14.81 megapascal. And I have to show you where is that maximum stress. You can see how beautifully the stress distribution has been displayed. This is an amazing view in itself. Here you can see, here almost no stress is there, so it is blue, and here, from here onwards, you can see how the intensity of the stress is increasing, and at this point there's a great intensity of stress. And in the opposite side, this is the maximum intensity of stress on these points. Same way you can see the intensity here, and then this intensity goes on dropping as it goes along this line. And as you can see, it is a little lighter in bluish color, so there's some intensity here as well. So basically this is how we can see the intensity of the stress, and how the stress is distributed along this line. And then let's see the displacement. Again, let's edit the displacement, and again make it automatic, and this is in millimeters. That's perfect. Clicking OK, showing you up the deformation. This is the point which will move from its, this is the point which will be moving from its initial position to the maximum, because when we'll be applying this stress, the force here, it will be freely moving. There's no hurdle to it, there's nothing like that to it. So here you can see there's a least movement over this zone on this rod, and there's some movement here as well, and you can see how that movement happens. Let's change it to automatic to better understand how this actually happens. Now let's try to animate. Now you can see how is this bending happening, and you can see this part is moving the most, though there's no stress on this point and the maximum stress is here. But anyways, this is moving, and this part is also moving, and these rods, both of them also moving, and these rods also moving, and the rest of the chassis is almost fixed. So this is the, which you can say, displacement in the model. And the last one is the strain, and again we can edit the definition to restore it back to the true scale. Clicking OK, you can see this is the strain that is being there in this model. The strain is basically a ratio of stress and displacement. So the initial, now to basically check. This is the strain. This is basically the ratio which shows how the stress is being applied in this model and how it is being faced or borne by this model or this chassis. So I hope you fully understood the concept of simulation or finite element analysis in SolidWorks, and you can export out it as well. You can save this deformation as a separate file, as a eDrawings file. So if I save it as an eDrawings file, clicking save, it's taking some time because it's a 3D model that it will be saving in. So this is the eDrawings viewer which comes shipped with the SolidWorks, and you can freely download it from the website. It's just free to download, and I have opened the model in this eDrawings viewer, and here you can see you can magically see all the stress distribution here in this 3D model, and you can send this stress distribution to your client or whoever is wish to see the stress distribution. So you can send him this, and here's this chart where from you can see the relevant intensity of the stress at any point by matching the color band with the stress value. So you can also prepare this kind of chart, this kind of 3D model for the displacement and for this train. I hope you enjoyed this video and you learned a lot of things, and I hope this video and this simulation made learning of SolidWorks enjoyable for you. Thanks for watching this video. Have a nice day.